Okay, so today we will be starting with indices lesson. So first we will see what are indices and then the laws of indices. Okay, now in previous classes you have already learned exponents. Now what is an exponent? Exponent, yes. Exponent is writing in the form of powers. For example, if I have 2 to the power 3 means what? This is an exponent. So an exponent consists of the base and the power, right? So expressing in the form of base and power is called as exponent. Yes, Aditya. 2 raised to 3 means multiplying to 3 times. That is 2 into 2 into 2. Yes, that is how we write. Now if I have say 5 into 5 into 5 into 5. So how can we write this in exponent form? So as we can see here, 5 is repeated 4 times. Yes, Sahil. So 5 is repeated 4 times. So we can write this as 5 to the power 4, right? So here we call 5 as the base and 4 as the power. It is also called as index, right? Or exponent, right? So we can call it as power, index, or exponent. Now we even have negative powers. When do we write negative powers? We write negative powers when it is in the denominator. For example, as we wrote 5 multiplied 4 times, if we write it as 1 upon 5 into 1 upon 5 into 1 upon 5 into 1 upon 5. So this I can write it as 1 upon 5 raised to 4, right? So this fraction also can be written in this form. Now we also have fractional indices. That is, the power can be written in the form of fraction also. We use these fractions whenever we are finding out nth root of a number. Okay, we use it whenever we are finding out nth root of a number. For example, say if I have square root of 2, right? We have to find out square root. Square means 2. So this root 2 can also be written in exponent form. So whenever roots is there, we always use the fractions. So this can also be written as 2 and the power here will be 1 by 2. So the power will be in fraction form. Right? Similarly, if I have fourth root of 5, fourth root of 5. So this we can write as 5 and the power will be 1 by 4 because here the root value is 4. Okay. So in general we can write it as root So nth root of any term, say a, can be written as a to the power 1 by n. Getting it? Okay. So we will see few laws we have which we have to use for in indices. Okay. Now we will see first one. Now we saw the first, that is nth root. Nth root is written as, say, nth root of a, where a is the number, can be written in exponent form as a to the power 1 by n. Right? This is one formula we saw. Next, we will see some laws of indices. Okay. Now, first law. We will see the first law. The first law states a raised to m into a raised to n. That is, if I have two exponents with common base and where we have multiplication of such exponents, then this can be written as a to the power m plus n. Okay. So what we say that if the bases are same where we have to multiply them, then we can add the powers. So a raised to m into a raised to n will be given as a raised to m plus n. So this is the first law. The second law states instead of multiplication, what if we have division? That is, if I have a raised to m divided by a raised to n. Now, whenever we have same bases and we are dividing, we have to subtract the powers. So this will be a to the power m minus n. So this becomes the second law. Now, this division can also be written as a raised to m upon a raised to n, that is in fraction form, right? So it may be the division sign or written as a fraction form with same basis. It will always be a raised to m minus n, right? Then now we saw when what happens when we have two exponents with same basis. Now what if we have a single base but two powers? For example, a raised to m into n, that is a raised to m to the power n. So we can see that there is a single base but there are two powers. So in such case what we do is we will multiply the powers. So it becomes a raised to m into n. Yes, it becomes a raised to m into n. Now what if we have two bases and single power? For example, a b to the power n. This can also be written as a into b to the power n. So we can see there are two bases having a common power. So this we can write it as a raised to n into b raised to n. Okay. So a raised to n into b raised to n. Now here we have multiplication of the two numbers, two bases a and b. Similarly, if we have division of the two numbers, that is, if it is a upon b to the power n. Yes, if it is in the form of a upon b to the power n. So this can be written as a raised to n upon b raised to n. Yes, Devi. Correct. Okay. So we will see what if we have negative power. Say if I have a raised to minus n. Now as we can see, the power over here is negative, right? When the power is negative, what we do? We want to convert that negative power into positive. Now whenever we have to convert this negative power into positive, we have to always take reciprocal of the base. So we can see here the base is a, it will be written as 1 upon a, and then the power becomes positive. Yes, so a raised to minus n is equal to 1 upon a raised to n. Then we have one general standard value, that is any number for that if the power is 0, that is if it is a raised to 0, a to the power 0, whenever the power is 0 irrespective of the base, the value will be always 1. Example, say I have minus 125 raised to 0, then it will be equal to 1. Say if I have 1 upon 25468 something raised to 0, then also the answer is 1. So, irrespective of the basis, if the power is 0, the answer will always be equal to 1. Getting it? Okay. Okay. Then we have, now as we saw here, sixth one, we saw a to the power minus n. What if we have a fraction? Say if I have a upon b to the power minus n. So as I said, what we have to do? We have to take reciprocal of the number of the base to make it to make the power positive. So a upon b can be written as b upon a, right? So since we took reciprocal of the base, the power becomes positive. So this will become b upon a to the power n. Okay. Okay. So these are the few laws which you have to remember, and we will be using these laws to solve the numericals. So just take down these laws, all the 8 laws, and the formula of nth root. So once you're done with writing it, just let me know. Did you finish writing? Okay. So everyone has finished taking it down? Fine. Then shall we start with the exercise? Okay. So we will start with the exercise. Exercise 6. So first is evaluate the first question, right? So in that we will do the first one. What is given is 125 to the power 1 by 3 is given. Now here we have to always see to it that the power is in the form of prime numbers. So what we have to do? We have to first write 125 in exponent form. Now children, what you all have to do is in your fair books on the right hand side you have to make a compulsory working column where you have to do your all rough works. Okay, so at the right hand side make a column, name it as rough work, and compulsory you'll have to do your rough work over there. You have to always show your working, right? So now here 125, you can see right what I'm doing in the rough column. Yes, so first we will prime factorize 125. So 125, now 125 goes in 5 tables, so I can write it as 5 25s are 5 5s are and 5 1s are. So 125 can be written as 5 to the power 3. Yes. So what we do is we replace 125 as 5 to the power 3, and then we write the given power 1 by 3 as it is. Now, as we saw in the law, right? We saw that a raised to m to the power n is written as a raised to m into n, right? So what we do is we will use this law and then we get 5 raised to 3 into 1 by 3, and we have to multiply the powers. So 3 will get cancelled. So we get 5 raised to 1, or the answer will be 5. Getting it? Okay. Then moving on to the third one, that is 1 by 5 to the power minus 2. Now as I said, whenever we have negative powers we have to convert it into positive. So here, which law we used? A upon B raised to minus n is equal to B upon A raised to n. Right? This is what we have to do. So what we have to do? We have to take the reciprocal of the number. So 1 upon 5 will be 5 upon 1. And then minus 2 will become plus 2. So if I simplify this further, it becomes 5 square upon 1 square. That is 5 square is 25, 1 square is 1. So we get it as 25 upon 1 or 25. Okay. Next, fifth one. Okay, fifth one. Now 32 can be written as, we will prime factorize it. 32. Now 32, we will prime factorize it. Since 32 goes in two table, we'll start with 2. 2 16s are, then 2 8s are, 2 4s are, 2 2s are, and 2 1s are. Yes. So 32 can be written as 2 to the power 5. So I'll write here it as 2 to the power 5 and then minus 4 by 5. Now as we know, we will be using the law a raised to m raised to n. So here what we have to do? We have to multiply the powers. So we get it as 2 raised to 5 into minus 4 by 5. Right? So now here 5 will get cancelled. So we get it as 2 to the power minus 4. Now how do we convert minus 4 to plus 4? By taking reciprocal. So 2 is written as 1 upon 2. Then minus 4 will become plus 4. Yes. So what is 2 raised to power 4? Yes. So 1 raised to power 4 will be, so I can write it as 1, yes. And 2 raised to power 4 is 16. So I can write it as 1 upon 16. Yes, it becomes 1 upon 16. Getting it? Shall we move on further? Okay. So next, moving on, eighth one. Okay, I'll do seventh one first. Now seventh one is minus 27 raised to 2 by 3. Right? Now how can we write minus 27? Now 27 can be written as 3 nines are 27, then 3 threes are, and then 3 ones are. So 27 can be written as 3 to the power 3, and minus 27 can be written as minus 3 to the power 3, right? So we will replace this minus 27 with minus 3 to the power 3. Yeah, and then 2 by 3 as it is. Now here again applying the law, we get minus 3 in raised to 3 into 2 by 3. So here 3 will get cancelled. So we get minus 3 to the power 2. So how much will be minus 3 to the power 2? That is minus 3 into minus 3. No, Sahil, it will not come reciprocal. Here the power is not negative, power is positive. We take reciprocal only when the power is negative. If the base is negative, we can't take reciprocal. Okay. So minus 3 raised to 2 can be written as minus 3 into minus 3. Yes, that will be plus 9. So be careful. You take reciprocal only when the powers are negative. Okay. So next ninth one will do. So this is given as 0.027 raised to minus 2 by 3. Now here we have the number in decimal. So what we can do? We will first write this decimal number in fraction form. So 0.027 can be written as in fraction form. We can write it as 27 by 1000. Yes, 27 by 1000. Okay, raised to minus 2 by 3. Correct. Now 27 can be written as 3 to the power 3, and 1000 can be written as 10 to the power 3. Right. Now as we can see in the fraction, both the numbers, that is numerator and denominator, have same power. So what we can do? We can take that power common. So we can also write it as 3 by 10 raised to 3, again to the power minus 2 by 3. So now multiplying the powers. So we get 3 by 10 to the power 3 into minus 2 by 3. So 3 gets cancelled. We get 3 by 10 to the power minus 2. Now as we can see, the power is negative. So we will take reciprocal of the base. So it becomes 10 by 3, and then the power will become positive. So it becomes 2. Yes. Yes. So any doubt in this? Have you all understood how to apply the formulas? Yes. So if you write it as 10 by 3 whole square will be 100 by 9. Correct. So it will be 100 by 9. Okay. Then shall we move on to the next? Okay. Next question number 2. In that we will do the second one. Okay. So what we have? Root 1 by 4 plus 0.01 raised to minus 1 by 2 minus 27 raised to 2 by 3 plus 3 raised to 0. Now as we can see here, we have 4 terms. So what we have to do is, we have to go on simplifying each term first. Right? Now as we can see, first one is root 1 by 2. Now as I said, a raised to root a can also be written as a raised to 1 by 2. Right? So this root 1 by 4, we can write it as 1 upon 4 raised to 1 by 2. Okay. Next term. Now next term what we have? 0.01. So this I can write it in fraction. So I can write it as 1 by 100 raised to minus 1 by 2. Then we have third term, that is 27. Now 27 can be written as 3 raised to 3. So I write it as 3 raised to 3 and the power 2 by 3 as it is. Then we know. Now here it is 3 raised to 0. As I said, whenever the power is 0, irrespective of the base, the answer is always 1. So this will become plus 1. Getting it? Okay. So now next. Now 4 can be written as 2 raised to 2. Right? So now 1 can also be written as 1 square and 4 I write it as 2 square to the power 1 by 2 plus. Now here we can see that the sign is negative, right? Minus. So what we can do? We can make it positive by taking reciprocal. So we get 100 upon 1 raised to 1 by 2. Then minus 3. Now here we have two powers. So what we can do? We can multiply that. So 3 into 2 by 3. So 3 will get cancelled and this plus 1 as it. Okay. Now here we can see that the powers are same for base numerator and denominator. So we can write it as 1 upon 2 raised to 2 into 1 by 2. Now here we can see 100 we have. 100 can be written as 10 to the power 2 into 1 by 2. Then minus 3 and here 3 got cancelled, so 2 remains plus 1. Right? Now in this step we can see here we can cancel 2, we can cancel here 2. So what we get is 1 upon 2 to the power 1 plus 10 to the power 1 minus. Now 3 square is 9 plus 1. Right? So this I can write it as 1 by 2 plus. Now 10 minus 9 is 1. Right? 1. So this I simplified, I wrote it as 1 and this plus 1 as it is. Now what we have to do is we have to add these 3. So 1 plus 1 is 2. 2 plus half will give you. So it becomes 2 plus half. So that will be 5 by 2. So the answer is pi by 2. Getting it? Yes, 2 1.5 also you can write it as. Okay. So you'll try solving till question number 6. Okay. You'll try solving it. We will continue in the next class. Sahil, no, we cannot write it in decimals. We have to write it in exponent form or in a fraction form. Okay, because this is indices lesson. Okay, so we'll continue in the next class. You all try question number 3 to 7.